Hello everyone. In this presentation, I will discuss my data-driven analysis of Netflix mobile app user experience using natural language processing and machine learning. The business problem I focused on is customer dissatisfaction with Netflix mobile application. Management suspect that mobile app experience may contribute to frustration, weaker customer satisfaction, and possibly higher churn. This is an important business issue because for many customers, the mobile app is one of the main ways they interact with Netflix. If the app performs poorly, users may become less engaged, leave negative reviews, or even cancel their subscriptions. To translate this business challenge into an analytical problem, I framed the project as a supervised text classification task. Specifically, I asked, can we use the written review text to predict whether a customer had a positive or negative experience? I used the review rating as a proxy for satisfaction. Reviews with ratings of 1 or 2 were labeled as negative, and reviews with ratings of 4 or 5 were labeled as positive. I excluded 3-star reviews from the prediction task because they are relatively neutral and more ambiguous. This forming is useful because if Netflix can automatically identify negative feedback at scale, it can detect customer pain points earlier and prioritize product improvements more effectively. The dataset came from Hugging Face and included 5,000 Netflix mobile app reviews. The main variables were review ID, platform, app ID, rating, review content, language, created date, and title. The most important fields for this project were the review text in the content column and numeric rating. One strength of this dataset is that it contains real user-generated feedback, which provides direct insight into what customers actually experience. Another strength is that it includes both Google Play and Apple App Store reviews, which allows some comparison across platforms. However, the dataset also has limitations. It is only a sample, not the full population of Netflix reviews. The review title field is mostly missing, so the analysis depends mainly on the review body text. Also, ratings are only a proxy for churn risk, so they do not measure actual cancellation behavior directly. Before analysis, I performed several data cleaning and pre-processing steps. First, I checked for missing values, duplicates, and data types. I found that the title column was missing for most observations, so I did not rely on it heavily. I also found many duplicate comments, so I removed the duplicate review text and reading combinations to avoid overcounting repeated feedback. Then I stripped blank text entries and standardized the text by converting it to lowercase, removing URLs, punctuation, and extra white space. I created a clean text field for NLP texts. I also calculated simple text features such as review length in words and characters. After cleaning and excluding neutral 3-star reviews, the final classification dataset contained 2,000 and 5,052 reviews, including 1,127 negative reviews and 1,425 positive reviews. Next, I conducted exploratory NLP analysis to understand overall patterns in customer sentiment and themes. The original rating distribution was highly polarized, with many 1-star and 5-star reviews. That is actually common in App Store data because the customers are more likely to leave reviews when they are either very satisfied or very frustrated. The overall average rating in the dataset was about 3.23 out of 5 points. I also compared ratings across platforms. Apple App Store reviews had a much higher average rating, about 3.84, while Google Play reviews had an average rating of about 3.07. In addition, the share of low ratings, meaning one-star and two-star reviews, was much higher on Google Play, about 44.65%, compared with 23.70% on the Apple App Store. This suggests that dissatisfaction may be more severe on the Android side, or that Android users in the sample encountered more product issues. To explore the text itself, I examined the most common terms in positive and negative reviews. Positive reviews frequently used words such as love, best, great, amazing, good, and excellent. Negative reviews more often included words such as bad, money, working, phone, keeps, account, pay, uninstall, and load. These word patterns already suggest some likely drivers of dissatisfaction, including technical performance, payment friction, and account problems. I then grouped negative reviews into approximate complaint themes using keyword-based screening. The largest theme was content availability dissatisfaction, which appeared in about 23.9% of negative reviews. Device and update issues appeared in about 25.1%. Payment and pricing complaints appeared in about 24.5%. Account and login issues appeared in about 50%. Playback and loading issues appeared in about 30.6%. This finding suggests that dissatisfaction is not driven by only one problem. Instead, negative sentiment seems to come from a mix of product reliability issues, account friction, billing concerns, and disappointment with available shows or plans. For feature engineering, I transformed the real text into numerical features using TF IDF vectorization. I used both unigrams and bigrams, meaning single words and two-word phrase. TF-IDF is a strong choice for text classification because it captures important terms while down weighting words that appear too frequently across all reviews. I also removed English stop words to reduce noise. For predictive modeling, I trained and compared two models, logistic regression and multinomial naive Bayes. I used an 80-20 train set split with satisfaction. So the positive and negative classes remained balanced across training and test sets. I also used five-fold cross-validation for a more reliable estimate of model performance. The best performing model was logistic regression. It achieved a test accuracy about 85.1% and a macro F1 score of about 0.85. Its five-fold cross-validated macro F1 score was about 0.836, which shows fairly stable performance. Multinomial naive Bayes also performed reasonably well, with test accuracy around 84.5%, but it was slightly weaker overall. Based on these results, I selected logistic regression as the preferred model. I also interpreted the model using its coefficients. Terms most strongly associated with positive reviews included love, best, great, amazing, and good app. Terms most strongly associated with negative reviews included bad, money, working, phone, account, pay, uninstall, and load. This is helpful from a business perspective because it shows that the model is learning meaningful language patterns rather than random noise. Based on the analysis, my main business recommendations for Netflix are the following. First, Netflix should prioritize mobile reliability improvement, especially around loading, playback, phrasing, and device compatibility. Second, Netflix should reduce account friction by improving login, household verification and payment visibility process. Third, Netflix should separate two product issues from catalog dissatisfaction because some complaints are about technical experience while others are about what content is available. Finally, Netflix should consider operationalizing a lightweight sentiment classifier that is one to monitor incoming reviews automatically and alert product teams when negative themes spike. In conclusion, this project shows that unstructured review tests can be transformed into useful business intelligence. Using NLP and machine learning, I was able to identify key sources of dissatisfaction in Netflix mobile app reviews and build a predictive model that classifies positive and negative feedback with strong performance. Overall, the results suggest that improving app reliability, reducing account and billing friction, and closely monitoring review sentiment could help Netflix improve the customer experience and potentially reduce churn. Thank you.